Hi, so this is the 3D modeling of the microprocessor traffic light controller, where these three LEDs are the main road LEDs, these are the side road LEDs, and these are the pedestrian LEDs. These are the two potentiometers used, and this is the buzzer. As soon in the beginning, when we start simulating, the main road green light will stay on. As the pedestrian presses either of the switches, the main road goes red and the pedestrian goes green, and the buzzer goes on. It will stay for 6 seconds as the potentiometer is being set for 6 seconds. You can see the green light blinks before it turns red. As you can see, there are two potentiometers. This potentiometer is to set the seconds for how long this green light will stay on, and this is the pedestrian potentiometer. As you can see the code, the value is 511 of this potentiometer. As soon as the value increases more than 511, the side road turns green and the main road turns red. Meanwhile, when the green light is on of the side road and pedestrian presses the button again, the pedestrian will get the priority and the same process repeats again.
For the second part of the assignment, we're using the Quanserve and Arduino that is connected through a serial peripheral interface (SPI) that is sending data 1 bit at a time sequentially using the clock. We can see that it's united by the voltage, the multiple output single input, the multiple input single output, the clock, and the ground to the Arduino, and the CS will be united to the pin number 10. We are also using the encoder 0 and encoder 1 that is measuring the angles of the arm and the inverted pendulum. Using the template that we were giving in class, through this program, the angle of the alpha will be controlled between -30 and 30, where the LED will be put on green. We will put the transfer function for theta and the transfer function for alpha, and then through the values that we have in the simulation, we will calculate the motor voltage. The motor voltage that will be input into the Quanserve have to be between -15 or 15, because in other range it will be fast enough to get damage the motor or the Quanserve, and then the values of the motor PWM will be converted. So for the third part of the video, we're gonna talk about the simulation. So we can see that we have the matrix here for the system, and then we are using the LQR to have the K to use the gains of the proportional and derivative in the Simulink. We are seeing that in the pole we have a positive value. That means that the system will be unstable. So we can see here that Simulink doesn't take degrees, so we change to radian to make all the system, and we only take the arm position. So we simulate in 30 seconds, and we can see here that when it's going to 10 voltage, it starts a little. Here in the side, we can see that the variation is 0.24. It's going to 10.24. So we can see that it's fine, and then we can see here that in the pendulum variation, it will take until 0.48. So it's completely fine, and the pendulum will be stable for a long time. And then we can apply some force, and we can see that it's completely stable.